Hello friends, today we start with electrification by electrostatic induction. Previously we have seen that how bodies can be charged by way of conduction or by rubbing. Now we discuss how bodies can be charged by electrostatic induction. Now first we are to understand what is electrostatic induction. Electrostatic induction, how we define or how we explain the phenomenon by virtue of which bodies can be charged by bringing another charged body near it, that is without any physical contact, keeping its own charge intact, is called as electrostatic induction. So this phenomenon is called as electrostatic induction. For example, consider a single metal sphere as shown in figure at A. Suppose it is to be given positive charge. Actually it is neutral because equal positive charges and equal negative charges are there, so it is basically neutral. So we are to establish positive charge on it. So we suppose we are to give a positive charge on it, and how we give it. Now figure A shows an uncharged sphere because it has equal positive and negative charge. It is electrically neutral. In figure B, this is figure B, an ebonite rod rubbed with acetate strip is brought near it, because when an ebonite rod is rubbed with acetate strip, it develops negative charge. Now positive and negative charges on sphere accumulate at the surfaces as shown. Now in figure C, surface distant from negatively charged rod is grounded. This is grounded. The surface distant from negatively charged rod is grounded, because in figure B the charges got separated. Positive charge accumulated near ebonite rod and negative charge at the surface away from ebonite rod. Now in figure C, when we ground the distant surface, the negative charge flows to ground. When we ground the distant surface with a conducting wire, the negative charge flows to ground. Now in figure D, ground connection is removed with charged rod in its position, and this negatively charged rod keeps the positive charge attracted towards its near surface. Now at surface to negatively charged, at surface near to negatively charged rod because of attraction. So in figure E, charged rod is removed. In figure E, charged rod is removed, and positive charge which was bound at surface near to negatively charged rod because of attraction becomes free. Here it becomes free and separates over whole surface of sphere. The sphere thus becomes positively charged. This is how we can electrify a neutral sphere with positive charge. Similarly, we can charge it negatively also. and that you do your practice. You bring a glass rod rubbed with silk cloth, which is positively charged, near the metal sphere, and then explain the process. That is your practice and your exercise, you do it. Now, some questions on electrostatic induction. Assignment 1 continued. Question number 6. How can you charge a metallic sphere without touching it? Means you have to explain electrostatic induction. And then question number 7. Establish negative charge on a metallic sphere by way of electrostatic induction. And this is a whole exercise. And question number 8. A glass rod rubbed with silk is brought close to two uncharged spheres in contact with each other, inducing charge on them as shown. Explain with diagram in each case what happens when the spheres are slightly separated. First question. Second question, the glass rod is subsequently removed. And third question, the spheres are separated far apart. This is how you have to answer the questions, by having the understanding of the electrostatic induction. And now, concept of charge. We explain concept of charge is the same. Quantity of electricity possessed by a body is called as charge. When two neutral dielectric substances are rubbed together in intimate contact, both are electrified. Due to friction between them, some of the electrons are transferred from one substance to the other. The substance which loses electron develops positive charge, and the substance which accepts electrons develops negative charge. Hence, both are electrified. And now, for example, we look at some examples. When glass rod is rubbed with silk cloth in intimate contact, glass rod loses electrons and becomes positively charged. Silk cloth accepts electrons, therefore becomes negatively charged. Thus, both are electrified. Now, from this we can understand that what is concept of charge. So, this introduces the concept of charge. That is how charge is developed on bodies. The basic is the same. When you take out an electron out of an atom, the atom becomes surplus in protons and becomes positively charged. And when you add an electron to an atom, it becomes surplus in electrons and it develops negative charge. Basic theory is that only. Here we do either by rubbing or by electrostatic induction. Now, SI unit of charge. SI unit of charge is Coulomb, denoted by capital C. Here the Coulomb denoted by capital C. Now, what is elementary unit of charge? We have to look at elementary unit of charge. The minimum charge that exists in nature is either the charge on an electron or proton, whose magnitude is plus minus 1.6 into 10 raised to power minus 19 Coulomb, and is known as elementary unit of charge. Plus 1.6 into 10 raised to power minus 19 Coulomb on proton, and minus 1.6 into 10 raised to power minus 19 Coulomb on electron. So, this is the elementary unit of charge. Now, we come to assignment. We continue with assignment. Assignment 1. Calculate number of electrons in 1 Coulomb electric charge. Similarly, calculate number of protons in 1 Coulomb of charge. And the answer would be 6.25 into 10 raised to power 18 electrons, and 6.25 into 10 raised to power 18 protons. Now, question number 11. If 10 raised to power 9 electrons move out of a body to another body every second, how much time is required to get a total charge of 1 Coulomb on the other body? So, answer is 198 years approximately. And then question number 12. How much positive and negative charge is there in a cup containing 250 grams of water? And you calculate the positive charge and negative charge. Of course, it will be equal. Either you calculate positive charge or you calculate negative charge. Okay. Now, thank you so much. Tomorrow we'll take up the next part of it. Thank you once again. God bless you.